Hi, how you doing? Okay, I've got another integral for you, okay? Because let's face it, we can never get too many integrals in our life, can we? Okay, this is integrating happiness with mathematics. Okay, right. I'm still in my Harry Potter gear. I just couldn't bother to change. Okay, right. Let's just have a go at this one. So I want to do the integral of. Oh, go on. Drop that. Okay, right. Up. Oh, good. Great. I want to do the integral of arcsine x dx. Ooh, that sounds difficult, doesn't it? Pause the video, give yourself a couple of minutes, okay, just see how you get on. Okay. How did you get on? Was that a couple of minutes? Rewind, pause it, okay, please? Yeah. Alright, so give you a clue, we're going to by parts it. Yeah. I prefer saying really use by parts, okay. So what I want to do is I want to write that as 1 times arcsine x dx, okay. And then the arcsine x, that's going to be what u is. I'm not really going to fit it on all over there, so I'm going to put it here this time. I'm going to break with tradition. U equals arcsine x. Why do I want u to be arcsine x? Because it would be ridiculous to have dv dx as arcsine x, if you think about it. Okay, so that would be just 1. So let's just do this one first, because let's face it, that's easier. And then we're going to have du dx is equal to, can you tell me please the derivative of arcsine x? No. It's a little bit tricky, isn't it? Unless you've memorised it or it's something you've used recently, you've probably forgotten what the derivative of arcsine x is. So let's just have a little recap. Okay, so we'll come back to this. Okay, we'll come back to this. And let's go for y equals arcsine x and try and differentiate. Okay, that should have been a spell in Harry Potter, shouldn't it? It sounds like it should be a spell. Differentiate. Okay, what are we going to do? How would that work? Okay, how would the differentiate spell actually work? I don't know. Okay. Right. Method is write it as sine y equals x. Yeah, do you see that one coming? Okay, so inverse sine of x. Just do the inverse of inverse sine, which is sine. So that's sine y. And then it's up to you really. You can use implicit differentiation, or what I would just do is I'd do right to left, differentiate dx dy is equal to cos y. I'm hoping you're happy with that. You should be happy with that. Okay. If you're watching these videos, you ought to be happy with that. Come on. If you lasted this long and you're still watching these videos, you are happy with that. Let's face it. Okay. Unless you're one of those just watching for the comedy, okay, in which case you're probably also a Big Bang fan of as well, Big Bang Theory. Big Bang Theory, people just sit there and laugh at the jokes and think, oh, that's funny, but people don't get it, let's face it. Okay. Do you really get all of Sheldon's jokes about physics and stuff? Do you? Yeah. People just laugh along, but it's nice to be happy. I've not got anything against that. Okay, it's always good to smile. Right, so we're going to have this then, dy dx, because that's our objective, wasn't it? 1 over cos y. And then we're going to think, I need to have it in terms of x, not in terms of y. So what we're going to do here? Well, clearly and obviously, I hope it's obvious, we're going to write it as 1 minus sine squared y, okay? So there's a lot of identities that go on in these sorts of integrals, aren't they? Okay, which is why trigonometry is so important, okay? And how can we write that? That's the same as 1 over root 1 minus, yes, of course, because sine y is x, therefore sine squared y is x squared. 1 minus x squared. And now you're thinking, oh yeah, of course it is, yeah. That is the derivative of arcsine x, okay? It is 1 over root 1 minus x squared. About now you're thinking, oh my gosh, this is probably hard. Not really, not really. Okay. Good, great, excellent, fascinating, challenging, thought-provoking, wonderful, entertaining, really, really cool, great, thumbs up, loving it. All positive things to describe what integration is. Okay. So let's just work this out then. So that integral, let's just call it I because, well, don't panic. This is not a reduction formula. Do not panic, okay? How do we know it's not a reduction formula? Because there's no awkward powers there. There's no higher powers. There's no n there. So it's not, I just have it right an I equals, okay? So uv, which is that times that, x arc sine x, and then subtract v du dx x over root 1 minus x squared dx. Okay, and that's fairly simple, isn't it? Okay, What do you mean, no, that's not fair? Yes, it is fairly simple. Okay, so arc sine x subtract. Well, let me make it simpler for you then, if you're still finding it a little bit difficult, okay? But maybe you can work out the answers, maybe in your head, before I get to the end of this. I'm going to write it as 1 minus x squared to the negative 1/2 dx, okay? Any simpler for you? What do you mean? No, it should be simpler for you, okay? That's just a inspection question, okay? And you're thinking, oh, okay, that helps. Well, I hope it does help, okay? When I say it's an inspection question, what that means is your answer's going to look something like this, okay? Because don't forget, when you differentiate what's in the brackets there, you're looking to see if you've got a multiple of that on the outside, and you do. Differentiate that, you get negative 2x, and that is, with the negative there, negative x, okay? So that's, yeah, that's that. If you just check, when you differentiate this here, you're going to have, let's just do it down here, shall we? You're going to have a half 1 minus x squared to the negative 1/2 multiplied by negative 2x, okay? And that gives you negative, well, it gives you that, doesn't it? Okay, gives you that. So, what does that mean? Oh, that's going to be positive. That's what it means, okay? Phew. God, I knew this. Yeah, because like I said, when you differentiate that being a positive term, you get the negative term, so just as long as you keep that positive, okay? So that means we can just rewrite this as x arc sine x plus, let's write it like this, because everyone likes the square root sign, and then where shall I put the plus c? I'll put it here, and there as well, just to be absolutely, yeah, plus c. Good, I hope you enjoyed that. Okay, hope you found that a nice simple integral.